Hi everyone. Good afternoon. Yeah, in the afternoon. Yeah, pardon my eyes. Someone said my eyes are kind of red. Uh, I've not gotten so much sleep, jet lag and everything. Yeah. Yeah. My name is Samuel Abada, GD Flutter, and that's. Um I co-organize the Flutter Lagos community in Nigeria. Um, I do some open source work. I'm the author of Maestro Workbench, some sets of extensions to help you manage your Maestro testing files for your mobile applications and web applications, and also Fig.dat for converting Figma design to Flutter tokens and team extensions and whatnot. I'm a part-time gamer. I play games in my free time, watch anime, and I like to identify as Batman. Yeah, today's topic, state restoration. It says bringing the dead states back to life. Um, what's state restoration itself? Why state restoration? So take for instance cases where you are filling some multi-step form, multi-pages form, right? And then for some reason, maybe a call comes in, you have to minimize the application, pick this call, or for some weird reason, right? You just left the main application for something else, and then you return back, and all the progress supposed to have done, what you've been doing is lost, right? And then the app, like, you have to restart the process again. So you go back to step one and start filling the form again, right? What exactly happened there? Two things, right? Or one main reason. This particular common to devices with low memory or low-end devices, right? So what happens there is the device, the OS, basically says, oh, okay, this application is no longer active, it's now in the background. So it tries to freeze up memory for the current active application. So hence, the idea of the state has died, it's killed the states of the application. So when you return back there, you have to like start the process all over again, or the app does not remember what you were doing, kind of. So what exactly is state restoration? It's a mechanism that allows you to preserve your UI state. It's the idea of saying the app remembers exactly what you were doing. Were you filling a form? Were you scrolling through some, I don't know, long list or whatever? The app remembers. And why is this important? The very first thing is to maintain user progress. As a user, I expect that irrespective of what I'm doing, the application should know what I was doing right before I left it. If I was on a particular screen, maybe a checkout page, for example, I expect that when I get back there, I'm on a checkout page, and whatever details are filled is in there, right? And of course, you don't want users to complain that the app does this, the app does that, and then you end up with 1 star on Play Store. Nobody likes 1 star, right? You all don't like 1 star. So let's dive into what makes up this state restoration. It looks like some big name, states and restoration. A couple of things. The very first one is the restoration manager, right? So this a core class that is responsible for managing the application state restoration process. So typically you don't deal with this guy most of the time. You don't deal with this guy. But it exists, right? Its work is to communicate with the platform, tell it to save this state and restore this state. You've also got a restoration scope. So this guy basically defines some kind of boundary in which your state is being managed. So in this boundary, there's some kind of bucket that we call the restoration bucket. Its work is just to hold data like a container. Restoration bucket is a bucket. We've also got the restoration mixin. So as a mixin, you apply it to stateful widgets whose states you want to preserve. right? This mixing provides you with methods and properties to manage and restore the states of the widgets. And someone might ask, why stateful widgets? Well, the basics of Flutter, we say stateful widgets. They are widgets that their states could change throughout the life cycle, right? They hold states. But stateless widgets, they don't contain states. They remain same throughout the life cycle. So since we are trying to preserve states, you expect that stateful widgets are the ones that hold the states. So you're applying the restoration mixing on the stateful widgets. All right, we've also got another class. It's called restorable property. Typically, in that we have primitives like integers, double, norm, type, Boolean, enums. So for all these primitives, we also have the restorable variants for them. So that's why I said they are special class that hold data that need to be stored. So basically, anything that's a restorable property can be saved and can be restored. We'll see how to use them. So the whole idea is something like this. So you have a restoration bucket. Whatever data you want to store, you want to save and restore, right? Restorable property. So they could be restorable integers, norm type, Boolean, enums, and whatnot. And I mentioned the restoration scope. So we have a scope ID, the boundary where all this is happening, right? So this is what it looks like, very simple. A bucket, keeping the data in the buckets, and then you have the scope, which is the boundary where everything is happening. So when we talk about state restoration, what exactly are we trying to restore? We say state. What are we trying to restore here? Oftentimes, when users interact with your application, they are moving through pages. Click a button, go to a particular screen, right? Or they are entering some data in the application. So that brings us to two things that you actually want to restore. The navigation stack, where has the user been to in the app, what pages have they gone through, right? And whatever data they've entered, have they filled some kind of form, right? Those are the two things you want to restore, or the two most important things to restore. We have primitives in that we've got data type like string, integers, double, norm, Boolean, enum, date time, time of day. They also have other Flutter-centric stuffs like text editing controller, right? And then Cupertino tab controller. We have the restorable variants for all of these. So for strings, we have restorable string. For integers, we have restorable int. For double, we have restorable double. For norm, restorable norm. So for every primitive, we have restorable x, where x is the actual primitive, right? So restorable time of day, restorable date time, restorable text editing controller, restorable Cupertino tab controller. We also have the nullable variants. So where you define a string as, when you define a variable as a nullable string, right? When you're trying to restore it, it becomes a restorable string n denoting nullable in this case. Similarly, we have the same for restorable integers, double, norm type, Boolean, enum, date time. I think these are all the restorable properties that we have today. Yeah, I think these are all of them. So for simple data types, they are restorable equivalents. And I mentioned that you could also restore navigation. So when you're navigating, you tend to do things like navigator of context push, if you're using navigation 1.0. Things like navigation of context push replacements, push and remove until. We have the restorable variants for this, right? So we have things like, instead of doing .push, you have restorable push replacements, restorable of any of these navigation APIs. So yes, how do we exactly do this? I mean, some code. The very first step for state restoration, right, is you have to enable state restoration. So state restoration generally is opt-in, right? It's not, while the framework gives you ways to set it up, right? You have to opt in for it. So you have to enable it first at the app level. And that is as simple as defining the restoration scope ID in your material app, a root restoration scope ID in the material app. If you are using the router API, you have material app.router. Very similarly, you have the restoration scope ID, the root restoration scope ID also. So this basically enables state restoration on the application. That's one. Secondly, you want to use restoration mixing in your stateful widget. This is very simple. This is the basic Flutter counter app. Just a counter variable, and then we tap some button to increment. Right? There's no special code here. But if we are going to restore the state of our counter, the very first thing is we use the restoration mixing. That's the very first line. Restoration mixing, that's one. Our counter variable goes from integer to restorable int. So when we compare it with the first slide, the earlier slide, see we have int counter equals to 0, but now we are having restorable int counter equals restorable int with the default value of 0. That's it. The next thing is you want to set the restoration ID for this particular widget. Here we save the ID as my home page. It has to be unique. You also have to define how this widget will restore its state. So you call the method register for restoration, where you register the restorable property, in this case which is the counter, and give it some ID. Right? The ID here I've used is counter. It could be anything. And then where I need the counter variable, that's line 47. Let's see. I should be doing something like counter.value. So there's a bug in our code. So line 47, we should then counter.value to get the actual value from the restorable. And we should not forget to dispose the property. It's very important. We should dispose. So what we should dispose? Just some code. So again, it's the default Flutter counter app. There's nothing special here. The very first thing you want to do is you want to opt in to state restoration. And you do that by setting the root restoration scope ID at the root of the app, the material app itself. It's what we've done here. The next thing is to identify widgets, right, screens that contain primitive whose states we want to restore. In my case here, I'm just having this home page. So you define the restorable property in this case. So I have a final restorable counter with the default set to 0. Then you have to create the unique ID for the widget state, which is the restoration ID, is what we have here. Then you have to tell the state, you have to register whatever property that can be restored. In this case, it's just a simple counter, right? So register this for restoration with the ID counter. The increment method, you pick the counter value and increment. Then there in the code, you call the property and then dot value. Do not forget to dispose once we are done with that. So that's how easy it is to restore states of screen on stateful widgets. However, we have cases of where you have custom objects. Oftentimes, as mobile developers, we are always working with custom objects, right? Simple classes that could contain other primitives. One example is just an example. It could be any class, right, that has from JSON and to JSON method with containing a lot of primitives. In this case, simple name and value. If I have data like this, how do I ensure that I can restore this data? Straightforward. I outlined a couple of steps here. The very first thing is you want to ensure that you have defined the custom objects. So you know what you want to restore this time. That's one. Then you want to create a custom restorable value from that class. And how do we do that? Let's go back to the code. Yes, so line, yeah, here it is. So now I want to restore a variable of type my custom object, which I have defined here. So what you want to do is you want to extend the restorable value. It's basically an abstract class that you can implement, extend to create custom restorable types. So the very first thing is you want to extend the restorable value, then define its default. You have to vary how it defines its default value. Then you have to tell it what to do when it's an update to its value, right? In this case, the restorable value itself is a change notifier. So this time, we want it to notify listeners. When you check the API closely, restorable value is of type restorable property. It is basically a change notifier. It is why once we update the value, we notify listeners. Yes, then we have to explain how this custom class can convert whatever value it's holding to that primitives. Primitives are basically our primitive data values, strings, ints, norms, and whatnot. In this case, the primitive, I'm converting to a map type here, right? So name, name, key value pair, key value pair. So the primitive, convert it to JSON, that's map. Then from primitive, once you get the primitive, check it's a map. If it's a map, then create my custom objects from that JSON value, right? So again, just to recap, the very first thing you want to do when you have custom objects that you want to restore is to extend the restorable value class. That's one. You have to create its default value. You override the create default method to tell it how to insert its default value. Then you want to override the did update value. You're basically describing to it how it's going to update itself. Then we also have to primitive and from primitive, basically converting itself back to that primitive that can be serializable easily, and then converting from primitive back to this class. So that's how we create custom restorable. Similarly, if you are to create a restorable for a list of custom class also, it's very similar. Class restorable my custom object list. You extend the restorable value itself, but this time we are restoring a list of custom objects. So the list of the class. You override the create default value, tell it how to specify its defaults, tell it what to do when the value changes, that's did update value. You describe to it how to convert from that custom class back to primitive, and how to convert from primitive back to this custom class. So it's the same thing, right? That's basically how you deal with custom types. And how do you use them? Simple. In our counter sample, we use the restoration mixin. So very similarly, we use the restoration mixin with restoration mixin. Then we define our variables, whatever variable is there. As you can see, this time I'm using the custom objects. Then you set its restoration ID, which is going to be a unique ID for this widget. You register whatever restorable property you have. So in this case, register for restoration these values and these values with these variable IDs. And you should not forget to dispose them off. It's very important that you dispose. And then in your build method, whatever widget tree we are constructing, we could get the values by doing my object.value and my object list.value. That's how that works for custom restorable types. So let's see this in action. So when building application, how exactly do we test that our app can restore states? Let me bring this. So on Android, you go to App Settings. You look for Developer Settings. Yeah, so you enable developer options, then then you enable this. Don't keep activities. So what this does is, once an application starts being the active application at that point in time, it kills the activity. So it says destroy every activity as soon as the user leaves it. So once you're on an application and you leave somewhere else, it kills the activity, right? So this is like a quick way for us to test that our app can, on low memory devices, the state will restore itself. So with this enabled, let's see how that will look like. So I'm going to do a quick one. I'm going to revert this back to our regular counter application and see how it behaves. Then we'll compare it with this with state restoration. So So we've reverted this code back to our regular default Flutter counter app. Just increments and decrements a counter. Yes, so here it is. Let's increment. We are at 10. Then let's minimize the application. Let's return back to it. So the application kind of restarted, right? But we've lost that state. So this does happen on low memory devices, low-end devices. So I'm just going to kill it, and then we apply state restoration and see how that is different. So we've killed the application. Let me revert everything. All right. So now we wait. So back to our application. Let's increment the counter to some random figure. And we minimize. Then we return back to the application. So the app restarts, right? But you still have the state in there. So this basically, this a simple demo. It works for different types. It's not only just, yeah, we've just done integers, right? Boolean, or even custom classes that hold lots of primitives. We could do that also on that. Yes. So a quick recap or a summary. There are basically two things you want to always restore: navigation and primitive data. For navigation, we mentioned that we could use, yes, for the primitive navigation methods, we could use their restorable variants. So cases where I want to, let's give a quick sample. So where I have navigator of context, then push. Instead of doing this and then supplying a material page route or whatever, you should do a restorable push instead. Right, so let's see. So similarly, instead of doing a push replacement and with a material page route or button-up page route, you should do a push. You should do a restorable push replacement. Right. So for each of these navigation methods, you have the restorable equivalent for them. However, the only navigation method that does not have a restorable type is pop. I mean, pop basically says go back, pop that route of the navigation stack, right? So there's no point trying to restore that. So yes, a couple of things to note or summary. State restoration is designed for ephemeral UI states. It's very important that we know this, UI states. When we talk about states in Flutter, we talk about two kinds of states: app states and local states, right? Local states are referred to as ephemeral states. It's very important to note that state restoration is designed for ephemeral UI states. So, okay, I'll show you other things. You should ensure to try as much as possible to always save the states, right? Your app should be able to survive low memory condition. So even at the minimum level, try restoring navigation, right? I think at the base level, do that. And I said save only the essentials. So if we are saying to always save the states, what do we mean by save only the essentials? What I mean is you should save only information that cannot be reconstructed later, or information that is not persisted. So data that you save to maybe a local DB like SQLite, Drift, or Hive, right? There's no point in trying to perform state restoration on those because you could always retrieve them from local storage, right? So you save only the essentials. Data that you could say gets from an API call. Like, why are you trying to restore that? I mean, you could get it from the server, right? For example, if you have a cat screen, right, I would expect that the cat has some kind of ID, and then you can restore the ID, right? So from that ID, you can always fetch the cat details from the server. It's very important that you don't overdo it. You don't overdo it. Android, for example, has a limit of 1 MB. So once, I've not exceeded that before, but according to the documentation, once you get there, you get a transaction through large exception. So I don't expect anybody to actually get to that limit because, I mean, what are we saving? Yeah, as software developers, we are beyond just building applications, right? Our job is to craft beautiful user experiences, right? So state restoration itself is not a feature, right? It's a promise to our users, a promise to our customers that our apps are resilient and are very reliable, and that our application will always remember their journey, to always remember wherever they are in the application. Keep that promise and you will elevate your craft. So yes, a couple of resources. Documentation on restoring state on Android, iOS, and the restoration manager. I think I created this project, Blue Lock, sometime last year. I don't remember why I called this Blue Lock again. What? I don't know. I guess it's too much of Blue Lock. Yes. So thank you. You can get the slides by scanning this. Yeah.
Thank you so much, Samuel. So we have time for Q&A. So if you have any questions, yep.
Hi, thank you so much for your topic.
Yeah.
I just wonder, I usually use a hydrated block to restore the state, and I feel it's maybe more better because we separate the layer. We use hydrated block for state and UI in different layer. But I found your way you use everything in same layer, UI layer.
Yes.
Which one is better approach for this?
Okay, so first thing, state restoration, right, does not really care about whatever state management you are using. That's one. Number two, I mentioned that state restoration is all about the UI local state, right? So if you are managing maybe app states globally within a block provider or iterated block or whatever, right, you can still do that. You don't have to bother yourself with trying to restore anything from there, since that's way it does the work. What this approach does is, let me give a very good example. Take, for example, you have a cart screen, right, on some checkout application you're building, and I would assume that your cart screen the cart has a cart ID, right? And with that ID, you could fetch the cart from your server, and then your block or whatever does all the states magic, right? What this expression is saying is, on that screen where you have the cards, you should restore the cart ID, because that's the most important thing that you need. And with that ID, you can still refresh whatever you need via your block to your server to get the cart itself, right? So state restoration does not interfere with whatever mechanism you have to manage your state globally, all right? It does not, yeah.
Thank you so much. If we use your way, it's not necessary to use a block beside this one.
Oh,
For
yes,
example,
yes. The two are distinct things.
You mean like I don't use a qubit or block since I rely on this way?
No. So again, the very first thing is dealing with local out states here. So states that is shared across screen, which gives the idea of state management, right? It's not managed by state restoration. All state restoration does is states that is local to that screen. It's not going beyond there, right? So on this place, I want to just restore this particular value, and it's just for this screen only, or for this widget or this component, right? So that's where its work ends.
Thank you so much.
Yeah.
I'm wondering, I guess, does the state restoration work only if the app is automatically closed, or if you kill the app, will it still work as well?
Yeah, so when you terminate the app yourself, right, like you've killed the app totally, right? So there's nothing to restore. Basically, you've killed the app, right? So, but cases where you've minimized the application, right, and the device OS decides to terminate the process due to some memory condition or whatever, right? That's where state restoration comes in. Okay, yeah.
Okay, so it's only when it's killed by the device itself.
A
not
device,
when you
yes, yes,
Oh, okay, got it.
yes.
Thank you.
It's also work when you click a deep link.
Yes, 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 because your deep link basically is some URI, right?
Yeah.
That contains some identifier. So it's expected that on that screen, right, you get and restore identifier. I think deep links are like what I give it, I call it some kind of command, right, that says open the application and fetch me this resource.
Yeah, kind of direct open another page, something like that.
Yeah?
Yeah. Deep link is direct open a page, but if the app when you killed is on another page, it's also restorable.
Yes, yes. So cases where your app is opened by a deep link, right, and you have the unique identifier, you could decide to restore that identifier. So cases where you minimize the application, right, and for some reason the device kills that process, right, when you resume back, as long as the identifier that came from the deep link earlier, you already saved this and apply state restoration on it, right, you could restore that identifier, and if it's some ID, you could use it to fetch whatever you're fetching from your server.
So it's kind of save many pages, not just current page.
Yeah, many pages, yeah. It's basically applied on a stateful widget. So.
Okay, yeah, thanks for sharing this. But I wonder, will this restoration will affect to the widget test?
Yes, there's some little quirks, right, as to how it plays out in tests. I think I have to attach a sample to, let me see if I have. I think I have a sample of that on the project repository. But yes, it plays a bit on widget test.
Okay, thank you. I will check.
Thank you so much for your presentation. During the demo, you had to turn on the developer option. Is it a
Yes.
necessary step?
Yeah, we were testing, right? So the fastest way to test this restoration, right, is via that method. So the idea of hot reload and hot restart does not exactly make you see state restoration in effect, right? So what we actually did is, let me see if I can bring that back. Yes, so it's for testing purposes. We basically told the device not to keep any activity. So as long as the activity is not active, just destroy it. It's for the purpose of testing and seeing how state restoration works out, right? On your actual device, I don't expect that your users will have that turned on, right? They could also have it turned on. We don't really bother about it, right? Ours is just our app can restore its state no matter what kills it.
Okay, thank you.
Yeah.
Thank you for your great presentation. My question is how to use different just push and restorable push. What is the different? What is the essential case of navigation?
Okay. So typically, when you're navigating between screens, right, you tend to do things like navigator of context push, right? You push a material page route, or you push replace a route, right? the point in doing a restorable push or a restorable push named, right? You're basically telling the application that this navigation history or navigation stack, please remember it, right? So when for some condition the activity is terminated and it's trying to recreate itself, right? Restore this navigation stack. So when you do a restorable push, it pushes to the navigation stack but remembers it, right? Restorable push replacements, it pushes the new route but remembers that you've done that already. So it can always restore that stack from navigation once you restore the app. So things like push, you have restorable push replacements, you have restorable push replacements. The only thing that does not be restorable is pop. That's because pop basically takes out of the stack, right? So why should I remember take it out of the stack if I'm already out of there, right? So yeah, is that clear?
Thank you very much.
Okay.
Sorry, just to build on that question a little bit.
Okay.
With your basically restorable routes, it has the app remember. We've gone through this partway. This is the state of the activity stack when the app crashed or was terminated at this point. But you also said earlier that the restoration parameters and variables I only remembered from the page that was on the top of the stack that was limited. Is that the case, or am I a bit mistaken about that?
I'm not sure I got the question correctly. Sorry.
So when your restorable, the routes are completely restorable, but the variables from the page, like the counter, for example. So you have a counter on each page of that stack, and you've gone 3 or 4 pages deep. Does it only remember the value of counter on the final page, the page that was on top of the stack, or does it remember from each page?
Yeah. So as long as you are doing a restorable navigation, right, and each of these pages have their own restorable value, right, it will remember the navigation and the value on these pages. Yeah.
All right. Thanks very much.
Anything else? Good. Okay, thank you, Samuel. So let's give applause to him.